Okay, hello and welcome everyone. So in this video, we are going to think about entry deterrence. And so this is going to be really important for our entrepreneur because once you've developed this new product or you've innovated or you've generated positive economic profits, that's going to be attractive to rivals. And we want to think about what are the types of things you can do to deter entry or to accommodate entry if it's going to be a foregone conclusion, such that you can remain profitable, hopefully, without running afoul of antitrust regulators. Because the last thing that our entrepreneur wants, besides entry, is to end up being doing something illegal, right? So we want to think carefully, though. And then actually, in later lectures, I'll talk about some of the antitrust considerations, and I'll talk about tacit collusion so that our entrepreneur is going to be able to recognize these things. We want to sort of avoid illegal practices, but also recognize when these could be present in a market, such as was relevant with the upstart Ben & Jerry's, who is sort of anti-competitively acted upon by Haagen-Dazs decades ago. So anyway, we want to think carefully about the issue of entry. The fact is, we have a situation where there's positive economic profits, and that is going to be really lucrative to rivals. And so one of the things we want to remember is that there are no long-run economic profits. So you might try to say that with a monopoly, there's going to be profits in the long run. Well, not in the very long run. So we're either going to have a situation where the barriers to entry are going to be overcome ultimately, or maybe the entire industry is rendered obsolete. Right? So you can think of like the famous typewriter monopolies or something like that. Well, that's pretty irrelevant today. You could think even of the utilities that are government protected natural monopolies, which mean that they could only be efficiently served by a single firm. Ultimately, with sufficient technology, you could come up with a situation where even those monopolies are no longer relevant, right? So the fact is, if we take a long enough shadow of the future, long enough view, you have a situation where there's just not going to be monopoly power into the super long run. For our entrepreneur now, we're going to just think about, well, how can we prolong entry, or how can we accommodate entry in a way that's going to generate positive economic profits as long as possible? So, obviously you don't want to take a super pessimistic view, because just as I'm telling you that there's no long-term economic profits, there's Bill Gates and Microsoft, which has been doing very well for a long time. Although you can think of the example of IBM, which had been an even stronger monopoly years and years ago, and now today they're still around. It maybe will once again be prominent with IBM Watson, but are just a shadow of their former selves. Anyway, so entry by competitors into your market can be a significant threat to your current and future profitability, as discussed. We're going to think about two sources of barriers to entry. So we want to think about exogenous barriers to entry, so passive entry deterrence. We want to think of endogenous barriers to entry, active entry deterrence. We're going to think about the actions that our entrepreneur can take to deter entry in one way or another, or the passive entry deterrent. You think about, like, what are the features of the market already, or the industry already, that serve as a barrier to entry. And we want to talk a little bit about what happens if entry deterrence isn't possible. Like, what can you do to prepare for accommodating entry? All right, so in terms of exogenous barriers to entry, there's a lot of forces, a lot of factors that can prevent entry into a market. So you could think of like government regulation or patent laws. You develop a product, you innovate, now you've got a patent for a number of years. You could have government regulation where you have a protected industry. You could have a situation where just to be able to operate, there's really large fixed costs, really large sunk costs of entry, and this could create a situation where there's not enough room for another firm, in the sense of, once you've made this really large investment, maybe any rival would need to make the same type of investment to be able to compete, but presumably would not be able to generate the volume of customers necessary to make that profitable. So this is what we mean by not enough room for another firm. That'd be such as a situation where there's economies of scale, where if you're producing at a very large output, you can drive your average cost down. Maybe there's this type of situation where there's learning by doing, where by virtue of having been in the market, you're able to get much more efficient and you have much lower costs by virtue of this expertise, typically embedded in your human capital. You think of the situation where there could be brand loyalty or switching costs, where customers might be uninterested or unwilling to overcome the barriers associated with switching. And then our question is, well, all right, so what if you don't have these natural barriers? Can you make decisions in such a way to be able to limit the possibility of entry? The things that you can do to limit entry. All right, so the first ideas you could think of, or the basic idea is, think of, you're the first business to enter the particular market. Being the first in the market, you might have a first mover advantage. Not all markets will have a first mover advantage. Sometimes a second mover advantage. Think of like MySpace and Facebook. But anyway, so can you use a first mover advantage by taking actions to make entry less likely? So you could think about how your actions, which could be a pricing policy, so long as it's not predatory pricing, could be advertising, could be investment in capacity, could be contracts that can affect the incentives for entrants to enter. So contracts could limit the size of the market because you've locked up a lot of consumers that a rival wouldn't be able to then deal with. Could be investment in capacity, where you've got the ability to greatly increase the quantity supplied at a given price, so on and so forth. The basic idea is you could do things to make entry unattractive to prospective rivals, such that rivals just think, oh, well, there's no profits for us if we come into this market. So some of our entry deterrence strategies would be building out additional capacity. So this would be a situation where you've now got the ability to flood the market or to increase your output and still remain profitable. It could be reputation. You've built up this strong reputation such that it's difficult for rivals to be able to overcome. Maybe there's some type of endogenous sunk costs that you could be making such that rivals would have to match that same type of investment, typically in quality or something along those lines. Or maybe you're using some type of limit pricing strategy such that prospective rivals are expecting that there's not as lucrative a market as actually exists. Maybe you're using some type of product location or product proliferation strategy where you've covered a lot of the characteristic space such that there's really no room for a rival to enter and to offer something that you're not. All right, so here's like the access capacity story. Here's the simple story. I'm going to rely on an application of game theory here. Suppose you've got a monopolist. You're selling a product, reasonably high prices. You're making $100,000 per year in profits. However, there's a new potential entrant coming into your market. I don't know, maybe your former roommate or something like this. It's stolen your code or whatever. I don't know. And so to enter, the entrant would have to pay a large fixed cost of entry, like scaling up the app or whatever it is, to be able to compete with you. You worry about the impacts on your profitability. And suppose you've got a situation where capacity constraints are important in this industry. Maybe you've got something where it's not possible for one particular firm to serve the entire market. Or maybe there's a way to be able to invest such that it is, or so on and so forth. You got capacity is relevant. The amount that a single firm can produce is relevant. All right, so you've got two possible strategies to take if entry is occurring. One thing you could do is you could accommodate entry. In this case, you'd keep your prices relatively high. You'd preserve some profits, but you'd let the entrant get a significant market share. Maybe this will end up giving you profits of $50,000. You're just kind of splitting profits. You could fight entry. You could invest in extra capacity once they have entered. And suppose this costs an extra $30,000. This will end up lowering your prices, sacrificing profits, but you'd hold on to market share. And it would cause the entrant to make losses such that maybe they'd leave the market. And then maybe you anticipate this will give you profits of $30,000 after you've made this investment. All right, so here's the game tree that I'm building out. So the first thing, let me talk about the game tree. Here's the potential entrant. They choose to either enter or not enter. Here's you. You choose to either fight or accommodate. If the potential entrant doesn't enter, they receive profits of zero. You retain your $100,000 per year. Suppose they do enter and you accommodate. They get profits of $30,000. You get profits of $50,000. Suppose they enter and you fight. They get profits of -10. You get profits of $30,000. Now in this game tree, I'm assuming the profits of $30,000 for entering and fighting is already, are already taking into consideration the $30,000 build out of capacity. So we've already accounted for that. This is going to be the profits you have after you've made that capacity build out. All right. Now we want to think about what's going to end up happening. So what's the equilibrium for this game and what's the difficulty? Well, here's how we solve this game. We go to the very end, we solve by backward induction. This is my payoff or your payoff. This is this player's payoff, 50 if they accommodate. They get 30 if they fight. Well, 50 is bigger than 30, so they ought to accommodate. right? So the issue here is 50 is bigger than 30, so we are going to expect, if I can do this, 50 is bigger than 30, so we expect they're going to accommodate. Well, if they're going to accommodate, then the potential entrant's going to look forward and they're going to say, wait a second, I'm staring between 30,000 or 0. I like 30,000. I'm going to go in. And so they're going to enter. Well, that one's straight. I don't know, whatever. So they're going to enter. You're going to fight. And then they're going to get 30,000. You're going to get 50,000. Again, we go to the end of the game. You consider what happens if I fight. I get 30. What happens if I accommodate? I get 50. Then we wrap back to the potential entrant. They look forward. They don't even worry about this minus 10,000 because they know you're for sure going to accommodate. So they're going to compare 30,000 to 0. They're going to say, I like the 30,000. So they're going to go in. And then these are going to be our, these are our Nash equilibrium payoffs. All right, so the problem is you would like to commit to fighting entry because that's the way to keep them out of the market. It's not a credible threat because upon actually entering the game, it's no longer rational. It's not sequentially rational is the game theory term. It's not sequentially rational for you to fight because 30 is smaller than 50. If we can figure this out, they can figure this out, so they always enter. What can you do to change this outcome? So what sort of steps can you take to make it a bad idea for them to enter? Well, suppose you thought ahead. Suppose you consider the possibility of investing in the extra capacity regardless. This allows you to price low and fight entry before the entrant even has the chance to enter. Now, this excess capacity costs 30,000, so you're going to incur the 30,000 even if the entrant doesn't enter, or if they do enter and then they accommodate. So we would think about like how's this going to change the game tree? All right, well, what I did now is, remember, this payoff already had the 30,000. I don't have to do anything with that one, right? This one already had the 30,000. Don't need to change this in any way, but I do need to deduct 30,000 from this one and 30,000 from this one because I've built out in both cases. I've decided to fight actually before they even enter. So I've reduced this from 50 down to 20. I've reduced this from 100 down to 70. This one doesn't get reduced because this already had that capacity build out. Now what do we do? Well, so we go to the end of the game. If they've entered, you're called upon to play. 30 is bigger than 20, so you're going to fight. And now the potential entrant's staring forward and they're saying, oh, if I don't enter, I get 0. If I do enter, I get minus 10. I'm not going to enter. So now we get the outcome where the rival is discouraged from entering the game. By having invested in capacity before the rival even considers to enter, you've created a situation where it's unprofitable for the rival to enter, and then they just actually don't enter. So now this is the credible entry deterrent strategy. Does the entrant enter? No. What are your profits in equilibrium? Your profits in equilibrium are going to be 70,000 because the equilibrium is going to involve them not entering. The basic idea here, by investing in excess capacity early on, which is going to reduce your profits, you're in essence committing to the price cutting even if whether the entrant occurs or not, and then if they do enter. This provides the situation where the entrant's not going to want to enter either way, and so you increase your profits in equilibrium because your profits in equilibrium here, are 70,000. Your profits in equilibrium where you don't build up the capacity is 50,000. Right, so the relevant comparison isn't the 100,000. That's not the equilibrium here. The equilibrium where you don't build up capacity at the very beginning is you get 50, they get 30. The equilibrium where you do build out your capacity either way, you get 70, they get 0. All right, the commitment must be irreversible or costly to reverse. Otherwise, it's going to be a situation where they're not going to believe it's not sequentially rational. So they're still going to enter because they're going to say, well, once push comes to shove, we're actually going to enter, and then you're going to back down, and you're not going to incur this the cost of the price war. All right. So the problem in our original entry game, well, the potential entrants think that if they enter, you are going to accommodate their entry, and so they're going to enter the game. The question is there another way that you might convince the potential entrants that you will fight and make conditions bad for them? Well, you could do this via reputational concerns. So suppose you've got a lot of potential entrants, maybe across time or across different markets, and you worry that entry is going to be a continual concern. You might just fight all entry, especially like relatively weak rivals, so that you can develop a reputation for fighting entry. So the comment is, even though it might generate lower current profits, in these cases might be beneficial to fight initial entrants, start a price war, even if they're relatively weak, to be able to develop a reputation for fighting entry so that others don't try to enter. right? This can lead to less entry in the future, less entry in other locations. Here's where we want to be you want to be really careful though. Fighting entry by pricing below marginal cost is called predatory pricing, which is generally illegal according to antitrust laws. And so you want to be careful not to be pricing below your actually long-run marginal cost, because that could be viewed as predatory pricing, and so we don't want to do that. But if you can price low and not be engaging in anti-competitive pricing practices, at least overtly, then this might be a reasonable entry deterrence. All right, now we want to think about non-recoverable sunk costs that can be used to prevent entry into a market. So sunk costs, non-recoverable costs that are incurred to enter a market. How can the sunk cost prevent entry? We're going to think about two versions of the world, one in which there's a sunk cost and one in which there's not. So consider a new product that can generate the following variable profits not including sunk costs. So suppose your monopoly profits are 100,000, the duopoly profits are 35,000 to each firm, so 70,000 total. So if there's two firms in the market, 35,000 each. If there's one firm in the market, 100,000 each. So suppose you came up with the idea first, you go first, you decide whether to enter, and then an entrant can possibly compete with you. Scenario A will be there's no sunk cost to develop the product. Scenario B, each one has to pay 40,000 in setup costs. Which one do you prefer? It's going to be scenario B, and so I'll show you that. All right, here's scenario A. Remember, in duopoly, where you both enter, you both get 35,000 in profits. In monopoly, where only you enter, you get 100,000 profits, they get 0. Where only they enter, they're a monopolist, they get 100,000, you get 0. And then when no one enters, the profits are 0, 0. All right, so what's going to happen? Let's go to the end of the game. Is a potential entrant going to enter? Well, here they're going to enter because 35 is bigger than 0. So if you enter, they're going to enter. And what about down here? Well, 100,000 is bigger than 0, so they're going to enter. So then what do? Well, you're comparing 35 to 0, you're going to enter. And so our equilibrium is going to involve both firms entering and splitting the market. Your equilibrium payoffs are going to be 35,000. What about scenario B? Now everybody's incurred a $40,000 sunk cost to be able to enter, right? So let's reduce this by 40,000 because the sunk cost of entry, reduce this by 40,000, this by 40,000. You don't have to do anything with these because if you don't enter, you're not paying this 40,000 setup costs, right? So I'm going to reduce these payouts. This is going to be minus 5, minus 5. This is going to be 60, 60. Now what do? Well, at the end of the game, not entering is better. So if you enter, the rival's not going to enter. What if you don't enter? They're looking at 60,000 versus 0. They'll enter and incur those setup costs. What are you going to do at the outset of the game? So looking forward, you're going to see 60,000 versus 0. You're going to enter. So now the equilibrium is going to be you enter, you get 60,000 in profits. They don't enter, they get 0. So what was the difference between scenario A and scenario B? Well, scenario A, there were no sunk costs to develop the product. Scenario B, each firm's paying 40,000 in sunk setup costs. And in scenario A, once a firm was in the market, a second could easily join and we could split the market and both be profitable as duopolists. However, in scenario B, because of this additional sunk cost that has to be incurred to enter, once one firm is already in the market, there's simply not enough room for another firm to be able to recover the sunk costs. Now, what if you have a situation where sunk costs simply don't exist for the product? Well, now you might be able to create sunk costs through your own actions. These would be your endogenous sunk costs. So the idea would be, what if there's a large investment you can make to reduce costs? So this would be like a large investment in process innovation, such as we discussed with the earlier lecture in the course. We're thinking about how a market could be previously competitive, and then the firm could invest in cost-saving technology and then either have a large or small innovation according to whether they're able to undercut the rest of the market as a single price monopolist. That's essentially this idea is, suppose there's a large investment you could make that could decrease the cost of production, and then you'd have this cost advantage. Now, if this is an environment where the investment wasn't cost effective without entry, such that the marginal cost decrease simply wasn't big enough to decrease the cost of the new technology, such as, I don't know, maybe this would be like the small innovation case. And then further, suppose you have a situation where if there is entry, now the investment might be worthwhile, even if it's not explicitly cost effective, because maybe this is indeed kind of a smaller innovation. However, it's enough to give you an edge such that a rival wouldn't want to be able to come into the market. What's happening here? Well, the investment would create some type of endogenous sunk cost, some type of thing that the entrant would have to match to be able to compete. Well, in this case, otherwise they'd have higher marginal costs, and the sunk cost would ultimately make entry less likely because their costs simply would be too high to be able to compete. There's other types of endogenous sunk costs you could do, such as advertising or different types of investments in product quality. And if you are advertising kind of a large amount as an initial entrant, it might be less profitable, maybe even unprofitable, for a potential entrant to try to gain a foothold in the market, because they're going to have to match or close to match your advertising expenditure just to be able to get their name out there. And so that's another situation. And indeed, like, advertising is definitely sort of a non-price competition, and the level of advertising could ultimately, or your investment in product quality, are two really good ways to deter entry in a way that's really unlikely to be anti-competitive through the eyes of justice officials. All right, so then there's the idea of limit pricing. Limit pricing I kind of like as this application of economic theory to be really clever. So suppose you're the only firm in the market. The optimal pricing policy would suggest you'd produce where marginal revenues equal to marginal cost. That's a standard single price monopoly. What would happen with limit pricing is you'd voluntarily price something lower than the profit maximizing monopoly price even before entry would happen. This is going to ultimately end up sacrificing current profits, but the idea is it can keep potential entrants out by making the market look all the less attractive. So the idea is the lower prices ultimately can make the potential entrants think that you have lower cost than you do, and I'll reinforce this with a numerical example in a second. The lower prices can make the potential entrant think that demand conditions are worse. Maybe you are pricing low because consumers simply aren't willing to pay that much. And it can make it hard for potential entrants to quickly gain market share, especially if there's switching costs, because if you're already pricing relatively low. And all these things taken together can make entry look substantially less attractive to any potential entrants. All right, so what I'm going to do now is I'm going to switch over on my Zoom share, which I'm using to be able to make this work out, is to my limit pricing notes. And what I want to do now is walk through the numeric example. So suppose we have this situation. Face this inverse demand, price is equal to 100 minus Q for each year. Fixed costs are 800 per year. Marginal cost is 10 per year, or marginal cost is $10. In year one, you have a single firm with the technology able to operate as a monopolist, and so you're the one. And suppose initially there's little danger of entry. What you do is you'd set the single price monopolist price. Then you'd be all set. So if our inverse demand is 100 minus Q, then the marginal revenue is going to be 100 minus 2Q, right? Same vertical intercept, twice the slope. And so set that equal to our marginal cost of 10. So solving, our monopoly quantity would be 45. Our monopoly price would be 55. And calculating profits, price times quantity, 55 times 45 minus 10 times 45 minus our fixed cost of 800, tells us that our monopolist is going to have profits of $12.25 for a single year. Or for 2 years, if there is no entry, $24.50. Now suppose there is a threat of entry. Suppose there's an incumbent that's in the market and an entrant that sees this price of 55. And suppose it's expecting the accommodate type response from the incumbent if the entrant were to come in. It's expecting a cournot oligopoly situation. All right, well, let's look at what happened in the cournot oligopoly outcome. So here's our profit from the perspective of one firm. We're assuming symmetry, and so we have the same inverse demand and we have the same marginal cost. And so here's the cournot profits. It's 100 minus Q1 minus Q2. That's like the inverse demand portion times the price. This taken together is revenue. Minus 10 times Q1 is the cost portion. I'm going to clean this up a little bit. So distributing this Q, I'll have 100 Q1 minus Q1 squared minus Q1 Q2 minus 10 Q1, and then I'll go 90 Q1. That's this 100 Q1 minus 10 Q1 minus Q1 Q2 minus Q1 squared. And then I'll take my derivative. This is give rise to my first order condition. So it'll be 90 minus 2Q1 minus Q2, which I will solve for Q1 as a function of Q2. This gives firm 1's reaction. More typically, I'd write this as 45 minus 1/2 Q2. And then this is firm 1's reaction to firm 2's quantity. By symmetry, firm 2's reaction to firm 1's quantity looks like this. To solve, we just plug one into the other and solve our system of reaction curves. And given that we know symmetry, that we have symmetry here, we could just use our Cournot formula for our optimal profits or optimal output, and that's going to be a quantity of 30 for both firms and then a price of 40. Where did I get that from? Well, I don't know if this is kind of getting cut off here, but since we have our inverse demand is of the form 100 minus Q, we have an inverse demand of the form 100 minus Q1 minus Q2. Our marginal cost is just C, so our Cournot equilibrium quantity is going to be A minus C divided by 3. So it's going to be this 100 minus marginal cost, which is 10. So A minus C is 90 divided by 3 is 30. So that's where this came from. And then my market price, well, if we're each setting a quantity of 30, the market quantity is 60, so the market price is 40. And then our Cournot profits are each going to be 100. I think, if I remember, I did do the Cournot. Here's if we do the full Cournot analysis. Here's what I had gotten up to in the video so far. Remember when I was going over the reaction curve, I said when I have 90 minus Q2 over 2, I'd actually like that as 45 minus 1/2 Q2. This gives me an easier algebraic result to solve. Here's my Cournot equilibrium. I'm solving a system of 2 equations in 2 unknowns. And so my substitution is I'm subbing in 45 minus 1/2 Q1, which is firm 2's reaction to firm 1's choice, in for Q2 in firm 1's reaction curve. Whoops, that's right here. And then solving, I'll get 45 minus 22.5 plus 1/4 Q1, or I'll get 4 Q1 is equal to 90 minus Q1. Oh, I'll get my quantity of 30 for each firm. And then we get our price of 100 minus 60. So I wrote down a price of 70 here. That's not right. It's a price of 40. And we saw that price of 40. I stated that correctly up here. Okay, so we've got that. Very good. That is all set. Now, this is telling us of what happens if we accommodate entry, right? What we just did, this Cournot duopoly outcome, this is just to say, suppose we had 2 firms in the market. This is what the incumbent's expecting. The incumbent this is what the entrant is expecting. They're expecting the incumbent to accommodate, and then they're going to split the market. All right, well, let's reflect on this. Our single price monopolist is going to get profits of $12.25 per year, or $24.50 for 2 years. With entry, both firms earn $100, so the second year. So the firm's profits are going to be, for firm 1, it's going to be $12.25 as a monopolist at first, plus 100 gives us $13.25 as their profits. The profits for firm 2 are going to be 0 plus 100, or 100. So now firm 1 is looking, wait a second, they're only having profits of 100. Maybe there's something we can do to drive those profits down, especially since I really like this profit of $12.25 I'm getting as a monopolist. So firm 1 thinks maybe they can deter the entrant. Suppose they set a price of 30, even as a monopolist. Now I've chosen 30 cleverly, such that this is the price that's going to make the duopoly unprofitable to our entrant. And there's a way to kind of do this. There's like thinking about the economic theory that goes beyond actually what we care about in this applied economics class, the entrepreneurship course. But I want to kind of convey the basic idea is, suppose the monopolist price is low as a monopolist. Now, I mean, this is a different story, right? If the incumbent's pricing at a price of 55, right, the entrant sees that and it's like, oh wow, that's great, 55 versus marginal cost at 30, excellent. Here, our incumbent is pricing at 30, and our potential entrant sees that price relative to marginal cost at 10, like, oh, it's not quite the same markup. So firm 2 is going to see this price of 30, and what are they going to believe? They're going to believe this is the monopolist price. And so they are going to reason that when they enter the price of 30, the monopoly price will fall once we have an oligopoly. They don't know the oligopoly price. All they're observing prior to entry is what the monopolist is doing. So firm 2 sees this price of 30, reasons that the price falls with entry, and the $100 profits is going to evaporate with it. We can see this. Let's look at the most optimistic case. Suppose the price of 30 that the initial firm is setting as a monopolist persists with entry, and they both set a price of 30. Suppose that happens in period 1 and in period 2. Firm 2 still wants to stay out, because then the profits are going to be the price of 30 minus the marginal cost of 10, which is a markup of 20, times 35 minus 800, which is the fixed cost, gives us a negative 100. Now, one of the questions you might have is, what's this 35 doing? Well, remember, if the firm is setting a price of 30, what's the quantity going to be? Our demand was price is equal to 100 minus Q. So if P is 30, Q is 70. And then we're just saying, all right, let's optimistically split the market. So half of 70 is 35. So the firm is initially, as a monopolist, setting 30. Let's take the most optimistic outlook for our entrant to observe, and suppose the price remains at 30 and they split the market. This is like the best case scenario for our entrant, and they're still making negative profits. So firm 2 ought not enter. And if this is the case, then firm 1 setting a price of 30 is going to be a monopolist both for period 1 and for period 2. So what ends up happening, firm 1 sets the limit price of 30. Firm 1's profits are going to be 20 times 70, they're producing the full amount, minus 800, which is 600 in the first year. And then once the threat of entry is gone, they go back to monopoly pricing and profits and set the monopoly price of 12.25. So their 2-year profits would be 18.25, which is better than monopoly plus cournot profits, which had been 13.25, right? So limit price profits plus monopoly profits is 18.25. Monopoly plus cournot profits, if entry happens, was 13.25. And notice also, these profits of 600, the limit price profits, are also better than the cournot profits. So even if the threat of entry doesn't go away, the firm's better off setting the limit price than they are as a duopolist. Now in this simple model, we are assuming we've got a single rival. We're assuming we've got 1 year is sufficient to deter the entrant. The real world's more complex, although look at this, even so, even setting the limit price, that's better than splitting the market. And so this is sort of an interesting example of limit pricing. Remember, the idea with the limit price is to choose the price so as to discourage entry into the market by feigning that the market is weaker than it actually is. So that's this idea. Limit pricing, lower prices make potential entrants think you might have lower cost than you actually do, or the demand conditions are less favorable. Makes it hard for potential entrants to come into the market. All right, last thing you might want to think about in terms of like other pricing schemes, well, you might have sign-up fees or two-part tariff that prevents entry by virtue of, well, locking consumers in. If they paid this annual membership as part of a two-part tariff, that's a switching cost. It's a sunk cost, although consumers might not view it that way. Other things equal, these switching costs can make it hard for the entrant to gain market share, hopefully discouraging entrants in the first place. There's also things like loyalty programs or frequent purchasing programs that have a similar deterrent effect by virtue of making this higher switching cost. Other things you can do is by virtue of product location or product proliferation, you can think about the characteristic space. You can think about the geographic space by where you're locating relative to where rivals can enter. So I mentioned this at the end of the product design lecture, but product proliferation involves locating at multiple spots. The idea is the more product space you cover, the more varieties you have, or the more locations you have, the more difficult it is for entrants to find a place where they can enter without competition. All right, so now we're thinking about the situation where it's not possible to be able to deter entry. So we think back to our original game, building excess capacity ended up deterring entry. So this was where we had the potential entrant. They could enter or not enter. You could fight or accommodate. If you fought, you're building out extra capacity, your profits would be reduced to 30,000. If you accommodated, your profits would be reduced to 50,000 because they would be splitting the market with you. And if they didn't enter, you'd have your full profits of 100,000. They'd have profits of 0. And then we saw this situation. This didn't actually deter entry because you had this incredible threat. They knew it was not sequentially rational for you to fight. Once they actually entered, you would accommodate. However, if you had the situation where you had built out the capacity prior to their decision, now we reduce these payoffs by 30,000. This payoff already included the capacity build out that happened after they entered. Now what you've done in this entry deterred with the capacity game is you've built out your capacity at the outset, so you're going to build out capacity whether they enter or not. And so you've already built in this capacity for the price war. This gave us a situation where if they did enter, you were going to fight, so they're actually not going to enter. You'd get profits of 70,000 in equilibrium, which was bigger than your profits of 50,000 in the equilibrium before. Well, what if that's not the situation? What if the game looks like this game, EA number 1 instead, entry accommodation game 1 instead? In this case, in the game we'll see, regardless of what you commit to, you actually won't be able to drive the entrance profits to zero. So you won't be able to deter entry. And here you wouldn't want to build the extra capacity. We'll see that here. So here's that example. Now what's the difference? We'll look at their payoffs. Look at their payoffs here. So suppose this is analogous to this one. Previously, if they don't enter, we get profits of 100. If they do enter, we accommodate. They get 30, we get 50. We get 30 if we fight. They get minus 10. Well, suppose they get 10 if we fight, right? This is just like that first one we just saw. Now what happens if you build out your excess capacity? Either way, we'll reduce this by 30,000, reduce this by 30,000. Oh, there's going to be a problem though. If the game looks like this and we build out, if the game looks like this, we reduce our payoffs by 30,000 for the building up the capacity. This drops down from 50 to 20. This drops out from 100 to 70. But there's a problem because if we end up actually fighting, they are going to get 10, whereas if they don't enter, they get 0. And so the problem is if they're facing this particular game, yes, if we build out our capacity, this payoff would get reduced to 70. This would be reduced to 20. This stays here. Yes, we would want to fight because 30 would be bigger than the 20 after we build out the capacity. However, the rival would be staring at this 10 that they would get versus this 0 if they don't enter. And so they're going to enter. So now we got a problem. However, suppose we had the situation like entry accommodation game 2. In this example, the excess capacity necessary to drive the potential entrance profit less than 0 is 60,000 rather than 30,000. This would keep the entrant out. Would you want to build the capacity? That's an interesting question. So actually here we're assuming that if we build out capacity even further, we could drive their profits to 0. So here what I've done is I've now reduced, right? I build out another 30,000. This one right here included a $30,000 investment in capacity. Now let's do another $30,000 investment in capacity to get us to the 60,000. So now this gets reduced to 0. This gets reduced to minus 10. This gets reduced to 40. That's how we get this game. All right. So now, fine. If they enter, we actually want to fight because 0 is bigger than minus 10. They would get profits of minus 10. That's good. If they don't enter, we get profits of 40. They get profits of 0. Okay, so what's going to happen? What's the equilibrium of this game? Well, the equilibrium of this game is they don't enter because they like the 0 better than this minus 10. However, let's compare the equilibrium of this game to the equilibrium where we don't build out the capacity. Oh, we would get 50,000 if we just accommodated, right? In the situation where it takes us a $60,000 investment in capacity to be able to deter entry, we'd actually rather accommodate and get 50,000 than we would build out the capacity and get the 40,000 after successfully deterring entrance. And so this is one of the things that's really careful to think about is like you can maybe deter entry by investing in capacity, but at what cost? And is it worthwhile? And so these are some things that are really important. In any cases, oftentimes we need to be able to focus on what is going to be getting us in the most profitable position once they've entered. So think about the optimal pricing, think about the optimal arrangement of capacity, realizing the implications on pricing as well as costs of capacity. Think on the important locational and product design issues, think about the important advertising ideas, and then we'll think about the possibility of tacit collusion, especially like if you're going to be a victim of tacit collusion, you want to be able to recognize tacit collusion. So this will be something we're thinking about in the future lectures. Anyway, I'll go ahead and conclude here. Hope you enjoyed the video. My computer crashed like 4 times. That's why I spliced together 3 different sections of it, which is incredibly frustrating, but hopefully it's worked out.